Okay, we're going to be finishing the last two sections in Chapter 2, Sections 6 and 7. So we're going to be talking about more on linear equations. In this section, we'll graph linear equations using the intercepts. Given a linear equation in slope-intercept form, use the slope and y-intercept to graph the line. Graph linear equations of the form x equals a or y equals b. Given the equations of two lines, determine whether their graphs are parallel or whether they are perpendicular. So we've got x-intercepts and y-intercepts. A y-intercept, which we've talked about before, the x is always 0. The y we refer to as b when we're talking about the equation y equals mx plus b. Okay. To find b, let x equal 0 and solve for y. An x-intercept, this time the y becomes 0 and you're trying to find a. So you let y equal 0 and then solve for the x variable. To find the intercepts of 5x plus 2y equals 10, and then they want us to graph the line. So remember that the first step was let x equal 0, and then figure out what y is. Okay, and then we want to find when y equals 0, figure out what x is. And so this equation that we're going to use, 5x plus 2y equals 10, if we plug in 0 for x, this term cancels out because 5 times 0 is just 0. So we're left with 2y equals 10. When we divide both sides by 2, y ends up being 5. So our x, y coordinate is 0, 5. And now they've already gone and plotted that for us. We walk to 0, go up to 5. We've got the coordinate 0, 5. Now, we're going to let y equal 0. So we would have 5x plus 2 times 0 equals 10. This time this is going to cancel out because 2 times 0 is 0. And when we divide by 5, we get x is equal to 2. So when we write our coordinate x comma y, we get 2, 0. So if we walk to 2, and because the y coordinate is 0, we wouldn't go up or down, we have that point. They've gone ahead and plotted another point. We could get another point by saying, well, to get from here to here, we would go down 5 over 2. So down 5 over 2 to get to the next point. And then they've drawn their line. Okay, graph y equals 1/3 x plus 1. Remember that y equals mx plus b is the slope-intercept form, and I'm recognizing the fact that this is in that form. So I already know that b is 1, so that y-intercept would be 0, 1. So that's your first step. That's what you want to do first. Right? We want to find the y-intercept, and we want to plot that. So plot y-intercept. So we go to 0, 1, plot that point. This, remember, is the slope, 1/3, which is rise over run, and that's what you want to take care of second. You want to start at the y-intercept and then follow the directions, which is to go up 1 over 3 spaces to get to your next point. And that point is 3, 2. Okay, So we went up 1 over 3. We started the y-intercept, then you follow the directions for the slope. If I want to graph y equals negative 3/4 x plus 4, okay, so it's already in the form, y equals negative mx plus b. Remember that the number one thing you need to do is plot your y-intercept first. Okay, and so our y-intercept would be the b part, so 0, 4. So go to 0, go up 4, and plot that point. Take care of that. The second thing you need to do is deal with your slope from this point. So our slope is negative 3/4. That's the rise over run. It's negative, so that means we're going to go down 1, 2, 3. And it's a positive 4, so we would go to the right 1, 2, 3, 4. And then we plot our points. Now, these are some special exceptions here. When the graph is just y equals 2, if you think about the table of what that would look like, if y, this is x and y, and everything here is 2, because y is equal to 2. It's never anything else. So if I let x be negative 1, it's still 2. If I let x be 0, it's 2. If I let x be 5, it's 2. So even they've plotted some other points here, but if we plot negative 1, 2, that would be here. If we plotted 0, 2, that's here. If we plotted 5, 2, that's here. So you can see that everything would be on this line that goes through, right? This is your y-axis. And so it's going through the point where y is equal to 2. So I always say put your pen or pencil on that point and just draw a line right through it. This one's the opposite. It's saying graph x equals 2. So if I go to x equals 2, which is right here, I want to draw a line straight through it. If we look at our table on this one, x is 2 every single time. So even when y is negative 5, x is 2. When y is 0, x is 2. When y is 3, x is 2. Right? So they plotted some of these points here. So 2, negative 5 is not plotted. 2, 0 is plotted. 2, 3 would be right here. So everything you can see goes through that line. The graph of y equals b, or f of x equals b, is a horizontal line with the y-intercept of 0, b. It is the graph of a constant function whose slope is 0. So, like that example that we just saw, if we've got y equals 3, then when we draw our coordinate plane, 1, 2, 3, we would go to where y equals 3, and we would draw a line that went right through it. Okay, our slope is 0, so let's just fill this out. We have y equals mx plus b. M is our slope, so our slope is 0 times x plus b. Well, your y-intercept would be whatever this is equal to. And you can see that this and this are the exact same thing because we don't have any x's, so there's not any there to put. So what happens when we get, so that's a horizontal line. What happens when we get a vertical line? Well, we're going to have x is equal to something. So maybe x is equal to 2. So if we draw us a coordinate plane, okay, at x equals 2, which would be right here, we would have a vertical line that went through there, if we talked about, remember that it says the slope is not defined. So when you do y equals mx plus b, okay, it doesn't have a slope. So we've just got y, I'm sorry. Ours is just x equals 2 because it doesn't ever even touch y, so there's no need for any y's here. It doesn't go through the y axis, so we don't have a b, and we don't have a slope because it's undefined, because we're talking about a vertical line that just goes through x equals 2. Two non-vertical lines are parallel if they have the same slope and different y-axis. So it says determine if the graphs of the lines y equals 2x minus 3 and 8x plus 4y are negative 6 to see if they are parallel. So what we want, condition number 1, is that if they're parallel, then they have the same slope and different y-intercepts. Well, the only really way that we've talked about how to figure out what the slope and the y-intercept is to solve it for y equals mx plus b. Well, the first equation is y equals mx plus b. We can tell that our slope is negative 2 here, and that our y-intercept crosses the y-axis at negative 3. But this one, 8x plus 4y equals negative 6, what doesn't say y equals? It's not in that form, y equals mx plus b, for me to tell if it has the same slope and a different y-intercept. So I've got to solve this for y by subtracting 8x from both sides. So I would get 4y equals negative 6 minus 8x. Then I need to divide everything by 4. Well, if we reduce this fraction, negative 6 over 4 is negative 3 over 2. Okay, if we reduce this fraction, negative 8 divided by 4 is negative 2 times x. So what is our, now this is written backwards, right? Our mx is in the back and our b is in the front, but we could see that our y-intercept here is happening at negative 3, 2. Negative 3 halves. Now let me remind you that you write this as a coordinate, right? This one would be 0, negative 3 over 2. And then my my slope is negative 2. Okay, so do they have the same slopes? Yes, they do. This one has a slope of negative 2. This one has a slope of negative 2. The y-intercepts need to be different. This one had a y-intercept of 0, negative 3, and this one had a y-intercept of negative 3 over 2. And you can tell that these two lines are parallel. They don't cross. So, yes, they are parallel. Looking for the same slope but different y-intercepts. In order for lines to be perpendicular, okay, they have to have their slopes have to be opposite reciprocals of each other. So their slope is opposite reciprocal. Okay, so if the slope, let's just talk about a few examples before we get into deciding this. But if my slope starts out at 4, okay, so if I wanted to say, well, what's the opposite reciprocal of 4? Well, the opposite of 4 would be negative 4. The reciprocal means that you're going to flip it upside down. So 4 could be written as 4 over 1. So when I keep this being opposite and flip it, it would be negative 1 over 4. So if I start out with a slope that is negative 1/2, okay, if I do the opposite reciprocal, the opposite would be positive 1/2, and the reciprocal would be 2 over 1, which is just 2. Okay, so they're saying that these two are perpendicular. And remember that perpendicular means that they make a right angle. Okay, a 90-degree angle. So they're starting off with a slope that is, the green line is a slope that is 2. Okay, so what is the opposite of 2? Negative 2. Now we need the reciprocal, so we're going to flip it. And remember that you could write 2 as a fraction so that you can flip it. So negative 1 over 2. And this is negative 1 over 2, or negative 1/2, is the slope of the new line. So it says determine whether the graphs of the lines y equals 4x plus 1 and x plus 4y, x plus 4y equals 4 are perpendicular. Okay, well, really you only worry about whether the slopes are opposite reciprocals. That's what we need to know. And right here we know that our slope, since this is y equals mx plus b, we know that our slope is 4 on this one. If I wanted to graph this line, which they're asking me to do, I could go straight to my table because I could plug this in the calculator. Or I could know that I need to plot my y-intercept, which is at 1. And then remember my slope is 4, so I would go up 4 and over 1. So 1, 2, 3, 4, and over 1 to get to my next point. And if I want to go backwards, I could go down 4 and over 1. That's kind of what that looks like. Let's fill this in real quick. Okay, so that's this line right here. Now let's talk about the other line. Let's say we want to, this one's a little bit more difficult because it's not solved for y equals, so it's not as easy to pick out the slope. So that's exactly what I'm going to do. I'm going to solve it for y, so I'm going to start moving things away from this y. So I'm going to get 4y equals 4 minus x. Then I'm going to divide everything by 4. 4 divided by 4 is 1 minus, now this is a little bit tricky since there's no number in front of the x. I know that it's a 1/4 times x. Okay, so what's my y-intercept here? Because that's what you plot first. Plot your y-intercept first. So I'm going to go to my graph and I'm going to go to 1. I'm going to plot that. So that's the same point as the other line had. But then this says to go down 1 to the right 4 for my slope. So from my y-intercept, I'm going to go down 1 and to the right 4. Okay, I also could do the opposite of that, which is go up 1 to the left 4 to get another point. Okay, so this, my new line, it does look like they are perpendicular to each other. I'm going to make sure, because I'm going to look at my slopes. So I'm going to take my beginning slope. The opposite of 4 would be negative 4. And then I need to look at the reciprocal of that. So if I flip that over, I would have negative 1/4. So yes, they are perpendicular. Okay. section 7, we're going to find equations of lines and applications. So we're going to talk about how to move these equations from one equation to another. So the example says a line has a slope of negative 3.2 and a y-intercept of 0.5. Find the equation of a line. Well, this case, they're just asking us to go y equals mx plus b. B is 5 in this case, because we've got our y-intercept here, and our slope, they're telling us, is negative 3.2. So that's it. That one was super easy. The point slope equation is written right here. M is the slope, and we've got y. If we're given a point and we're given the slope, then we can write that equation of a line. Y minus our first y coordinate times m times x minus our first x coordinate. Okay, they want us to find an equation of the line with a slope that contains, that's a slope 3 that contains this point. So they're wanting us to use the point slope formula. Okay, so the y and the x, the regular y and x without the subscripts, just stay the same. This would be my x1, y1, this point right here. So we would do y minus y1, which is 7. M is our slope, and they told us our slope is 3. X minus x1, which is our x coordinate. Okay, now most of the time you're not going to leave it this way. We would want to move this around so it said y equals. So that's not that hard to do. This is supposed to be minus . Okay, so we would add 7 to both sides of our equal sign. That would give us y equals 3 times x minus 2 plus 7. Now we can distribute this 3, so that would be 3x, and then 3 times negative 2 is negative 6 plus 7. Y equals 3x. These two can go together, so plus 1. So this is method 1. We use the point slope formula to find the line. We could start out with the slope-intercept form, which is y equals mx plus b, and use it to get our equation of the line. Okay, in this one, we actually let this be x and y. We know that m is 3, and so you would say, okay, the goal is to find b this time. So what you would do is say, well, y is 7, right? Y is equal to 7, so we're going to put 7 here. M is 3, that's our slope. X is 2, right? X is 2 plus b, that's what we're looking for. So we're going to say 7 equals 6 plus b, subtract 6. 7 take away 6 is 1. So the y-intercept is 1. Then if you go back to your y equals mx plus b, now you know your slope is 3. They told us that in the beginning. And then your y-intercept, we just figured out, was 1. So you get the exact same results no matter which one you use. I think this method is a little bit easier. Okay, so it says find an equation of the line containing the points 2, 2, and negative 6, 4. Well, this time they didn't tell us the slope, so our first step is going to be finding the slope. y2 minus y1 over x2 minus x1. So we've got 2 points. It doesn't matter which one you call x1, y1, and which one you call x2, y2. I'm just going to pick. So when we're doing this, we're going to say y2 take away y1, so negative 4 y2 minus y1, and then x2, which is negative 6, minus x1, which is 2. That's going to be negative 6 over negative 8, and if you reduce that, you're going to get 3/4. So there's my slope. If I want to use point slope form, y minus y1 equals m times x minus x1. We've got y minus 2, and I'm using this for my x1, y1. I never changed it, so I'm just letting that be the same point. My m, we know that was 3/4 because we solved that and got this. X minus x1, well, my x1 is also 2. So we would keep going and we'd say y minus 2. We would distribute this. So 3/4 times x minus 3/4 times negative 2 ends up being negative 6 over 4. And I already have the minus sign, so I don't need to write another one of those. Sorry. Okay. So we've got y minus 2 equals 3/4 x, and then that would reduce to 3 over 2. Now we need to add 2 to both sides, so y equals 3/4 x. Negative 3/2 plus 2 is going to end up being a positive 1/2. Okay, now if I want to use the slope-intercept form, we would start out with this. Now we do know the slope is 3 over 4. We found that out in the beginning, so I can put that there. It doesn't matter which point you use, 2, 2, or negative 6, 4. I'm going to use the first one they gave me. So both my x and y are both 2's. So this would be a 2. And remember, when you're using this form, the goal is to find out what b is, and then you can plug that back in. So we would get 2 is equal to 3/4 times 2, which ends up being 3/2 plus b. Okay, so now we've got 2 is equal to 3 over 2 plus b. We would subtract 3/2 from both sides of our equal sign, so we would get 1/2 equals b. So now we know the rest of the stuff to plug in the formula. Y equals 3 over 4. I'm getting that because that's my slope, and I found that in the beginning. And then plus 1/2 because that's my y-intercept that I just found. Find an equation of a line containing the point 1, negative 5, and that's parallel to this line. If it's parallel to this line, remember that it has the same slope. So that means my slope is negative 3. Okay, so I'm going to use the y equals mx plus b form. So we've got negative 3 for the slope. For y, we know that y is equal to negative 5. X is 1. I'm getting this from right here. This is supposed to be my x and my y. And then plus b. So that's negative 5 equals negative 3 plus b. Add 3. So negative 2 equals b. So now we can say, well, y equals negative 3x minus 2. That would be our y equals mx plus b that we found. Okay, find the equation of the line containing the point 7, 1, and it's perpendicular to 7x minus 2y equals negative 2. Well, if it's perpendicular, remember that it has the slope is the opposite reciprocal. So the first thing we have to do is find the slope. To find the slope, the best thing you can do is to move it around so that you've got y equals. So we're going to subtract 7x. So negative 2y is equal to negative 2 minus 7x. Divide everything by negative 2. So y is equal to negative 2 divided by negative 2, that's 1. This is going to be a positive 7 over 2 times x. Okay, so that means that my slope would be 7 over 2. So if we take 7 over 2, what's the opposite? Negative 7 over 2. The reciprocal would be negative 2/7. So taking that fact and using this point, 7, 1, this would be my x and y. I could go y equals mx plus b. So negative 2/7 would be my new slope. 7 would get plugged in for x. I don't know what b is, but y is 1, so we would have 1 over here. So 1 equals negative 2 plus b, add 2, so b is 3. So the line that's perpendicular would have a slope of negative 2/7 times x, so negative 2/7 would be the slope, times x plus b, well, b is 3. Okay, last question. For a service call, Calvin Appliance charges $35 service fee and a $55 per hour for labor. Formulate a linear function that models the total cost of service call, and they want us to call that C of t, where t is the number of hours. Well, they're going to charge us $35 up front plus $55 for every hour. They're telling me to call t the number of hours. So they want us to graph that. Well, the y-intercept would be at 35. So that's why they've got this dot right here at about 35. And then to get to my next point, I would want to go up 55 and over 1. So we could go to the graphing calculator and also make a table, because it's kind of hard to see exactly where that is going to fall. So we've graphed the model. Use the model to determine the cost of 2.5 hour service call. Well, 2.5 hours is about right here. And so if we go over, looks like we're halfway in between 150 and 200. So the cost of that call would be $175. We could also say 35 plus 55 and then plug in our 2.5 right here for t and see what we actually get. And that comes out to exactly 172.5. So the graph gave us more of an estimate. This would be our exact answer that we would get from the equation. And that's the end of chapter 2.